All right, so this is part 4 in a series of videos I'm making where I'm explaining why the numeral called DEC looks the way that it does. So DEC is the numeral that comes after 9 when counting in base 12. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, DEC, L, and then DO for a dozen. So the symbol for DEC is basically an X, looks like that, with two little wings on either side of one of the lines that crosses the X. So I'm just going to put my whiteboard behind here so you can see this all more clearly. So in the last video, I explained how drawing this line, we go up the length of 2.5, and then over, you go up, basically up 1 over 0.7, up 1 over 0.7, then half of that, and over half of 0.7. So we get a height, that's 2.5 and 2.5 of 5, and then 5 and 5 is 10, or DEC. So that's how we have the value of the number that the numeral is representing incorporated in the symbol, and that goes for all the numerals. They all have that feature. They all have the other feature of being attached to their corresponding circle in the series of circles. Square root of 1, square root of 2, square root of 3, etc. So this circle is the square root of 10. So when we place the numeral on that circle, these are the proportions that emerge. So this length here was 0.5. So we went over a distance of 0.5 and 0.5. So we also have the decimal version of 10 incorporated in the symbol. So now what we want to do, we've basically connected these two lines, but here we're not doing the same line. That the X isn't perfect, it's a little bit off. So we've created the hypotenuse of a triangle. One side of the triangle has the length of 5. What's this bottom length here? Well, basically we went over the coordinates of this point here is negative 1.6. So we are basically multiplying that by 2. We're going, in that direction and that direction. So 1.6 times 2, or added to itself, gives us a length of 3.9. So we have 3.9 and 5. So when we divide 3.9 by 1.3, we get 3. When we divide 5 by 1.3, we get 4. So this becomes a 3 and a 4, and then this length here is 5. This is a 3, 4, 5 triangle, where the hypotenuse is going to be 5 times the length of 1.3, which is 6.3. So we have a 3, 4, 5 triangle on this side of the numeral. On this side, we are connected to the geometry of the circle, where we can divide the circle perfectly into 360 degrees. That's a foundational geometric pattern that we're missing in base 10, but does exist in base 12. I've written a book explaining how we can do that or create that diagram. We have the length of 5 and 5, 10 built into the system. So that's why the numeral for DEC looks the way that it does. Somebody created that to look